In the previous class, I discussed about the use of potentiometer, its construction and its working. And in the previous class, we have seen that how potentiometer is used to compare the EMF of two cells. Now, and in this class, we will learn about the determination of internal resistance of cell by using potentiometer. The schematic diagram for measuring the internal resistance of a cell using potentiometer is shown. This is our potentiometer. This is the wire AC, and we have this is external battery, and this is your state, and this is K1, and I current is flowing through this. Again, we see that here this is our cell whose internal resistance has to be decided, and this is a resistance box where we can change the resistance of in the circuit, and this is another key2 to switch on this circuit or this loop. Let's see step by step how we have to do the to find the internal resistance of a given cell. Close key K1, we have to close this, keeping K2 open. Firstly, slide the jockey on the wire. Consider at N1 no deflection through G is found, that is no deflection in galvanometer is found. At this stage, the PD potential difference across A and N1 is equal to the EMF of cell. That is, in this case, if it is open, then if K2 is open, then it will be open circuit. This cell will be in open circuit, and so the potential difference across this point A and N1 will be equal to the EMF of the cell, and this is the case of open circuit. Hence, E will be equal to VAN1 equal to phi into L1, where phi is the potential per unit length, where L1 equal to AN1 length of the wire AN1, and phi is the potential difference per unit length of the wire. Step 2. Now close K2 key2 so that known resistance R is connected to the cell. Cell sets current through R. Slide the jockey. Consider at N2 no deflection in G is found. Then terminal PD of the cell is equal to the PD across A and N2. Hence V equal to A and 2 equals to phi into L2. This is equation 2, and the circuit diagram for second case is here shown. That in this case, this K2 is closed and current is flowing in this and this case, and a time when we slide the jockey, a time reach when the current through galvanometer again becomes 0, and in this case potential will be equal to V into A and 2 equal to phi into L2, where L2 is the distance between A and N2. Now dividing 1 by 2, we have E by V equals to L1 by L2. This is equation 3. Again, we know that from figure in this circuit, if it is a EMF cell with resistance R, and this is the external resistance. In this case, we see that from figure V equal to E minus IR, it had been shown that is terminal voltage is equal to EMF minus I into R. Now this implies IR will be equal to E minus V, and R equal to E minus V by I, or E by I minus V by I. This is equation B. Again, we know that V equal to IR. potential difference about this point is equal to V equal to IR. Hence I equal to V by R. Using this in equation 2, we get R equal to, in this equation, E by V by R minus V by V by R equals to RE by V minus R. Hence R will be equal to R into under bracket E by V minus 1. This is equation C. Using 3 in equation C, we have calculated earlier in equation 3 that E by V is equal to L1 by L2. So we have R equal to R into under bracket L1 by L2 minus 1. Thus, knowing L1 and L2 and R, the external resistance, we can find the internal resistance of the cell. So we have found the internal resistance of the cell using these values, because these values are known. Now some important point regarding this part. Note, in second case, we also take no deflection in the galvanometer, so that current in AC, that is in wire AC from A to C, remains constant, and we can apply V proportional to L. Second, EMF of the driver, that is main or auxiliary battery, should be higher than the EMF of each of two cells being compared to obtain the balance point. Otherwise, null point or balance point can't be obtained. So this is clear from the line that auxiliary battery, that is external battery, should be of higher EMF than the battery who we find we have then the battery whose internal resistance has to be calculated. A potentiometer of length 100 cm has a resistance of 10 ohm. It is connected in series with a resistance and a cell of EMF 2 volt and of negligible internal resistance. A source of EMF 10 millivolt is balanced against a length of 40 cm of potentiometer wire. What is the value of external resistance? Let's see how it can be solved. Now it is shown, it is seen in the situation. This is our potentiometer wire AB, and it is a cell of EMF 2 volt, and it is connected with a resistance R. And another another cell is connected with point B, whose EMF is 10 millivolt, and it is connected with a galvanometer and a joy to slide on the wire AB. From the theory of potentiometer, we know that VCV equal to E, VCV equal to, because no current is flowing through galvanometer, so it will be in open circuit, and the potential about terminal will be equal to the EMF of the battery. So VCV equal to E equal to 10 millivolt if no current is drawn from the cell. Now in this, I equals to E by R plus RAB, because this is the resistance of by RAB. Hence VCB, and again VCB, potential difference across A and B for this cell, I into RCB, or putting the value, we get E1 by R plus RAB into RCB. This is question 2. Now from 1 and 2, E equal to E1 into RCB by R plus RAB. And value of RCB is RCB from C to B, length of C is RCB is 10 by 100 into 40 equal to 4 ohm. So using this value, we have the value of E is given 10 to the power minus 3, 10 into 10 to the power minus 3 millivolt. This value is 10 to the power minus 3, and E is given 2 into 4 by R plus 10. Or solving it, finally we get 10 to the power minus 2 into R plus 4 equal to 8, or this implies R plus 4 equals to 8 by 10 to the power minus 2 equal to 800, hence R equal to 800 minus 10 equals to 790 ohm. Answer. Next, the meter bridge wire AB is 100 centimeter long. When AC equal to 40 cm, no deflection occurs in the galvanometer. Find R. This is the case of Hindustan bridge, because no current is flowing through the galvanometer. So this ratio of this to this will be equal to ratio of this resistance. We are taking resistance. So 10 ohm by RAC, 10 ohm by RAC, or resistance ratio of this to this will be equal to ratio of this to this. So 10 by RAC divide equals to R by RCB, where RAC represents the resistance of length AC and RCB represents the resistance of length CB. This implies 10 by R dash 40 into R by R dash into 60, where R dash is the resistance per unit length, and 40 is the length of AC, and 60 is the length of CB. This implies 10 by 40 equal to R by 60, hence R will be equal to 15 ohm. Solving this, we get R equal to 15 ohm. Answer. Where R is resistance per unit length of the wire. Next question. Question: the potentiometer wire AB is 600 centimeter long. A. At what distance from A should the jockey J touch the wire to get zero deflection in the galvanometer? Get zero deflection in the galvanometer. B. If the jockey touches the wire at a distance 560 centimeter from A, what will be the current through the galvanometer? Solution of A. Let at C, this is the point C, we get zero deflection in G, then RAC is equal to L into RAB by 600. This is the resistance per unit length. So multiplying this length will give the resistance of this length, which will be equal to RAC. RAB is total resistance of wire AB. So L into, now it is given, RAB is given 15R. So L into 50R by 600. Now current is flowing through this is I. So I will be equal to EMF divided by total resistance, which will be RAB plus R. This is the R value, that is total resistance, because this resistance and these are in series. So E by 15R plus R equal to E by 16R. Here the length is shown, that is A to C is L. So from C to B will be 600 minus L, because whole length is 600. And this is the jockey needle. From theory of potentiometer, now we know that VAC, here we see that at this point, when this point C, jockey is at C, there is no deflection in this current. So terminal voltage between the A and C will be equal to EMF of this cell. So we can writing VAC, that is terminal voltage between A and C, equal to E by 2. The EMF of this cell is given E by 2. And now this implies VAC will be RAC into I equal to E by 2, or this implies RAC, value of RAC. RAC is equal to L into 15R by 600 into E by 16R equal to E by 2, and R will cancel, E will cancel, so L into 15 by 600 into 16 equal to 1 by 2. This implies L into 600 by 16 by 15 into 2, solving this you get 40 into 8 equal to 320 cm. Answer. Now in the next case, let I dax with the current through G. In the next case, we slide the jockey again, and now the current flows through the galvanometer, that is in this circuit, and let this current is I dash. Now since I current is flowing through this, so at this point I dash will come in this direction, and I minus I dash will go in this direction, and at this point again this will be I. So current, let I dash be the current through G, given AP equal to this distance is given, AP equal to 560 cm. So RAP, that is resistance of this length, will be AP into 15R by 600, or solving we get 40R. Hence RPV will be 15R minus 40R equals to R. Now the circuit diagram is shown here. Now applying KVL in loop ABCD, which will be equal to minus I dash into 40R minus IR plus E equal to 0. This is equation 1. Or minus 14 into R plus minus I dash into 40R minus 2 into IR equals to E. And again KVL loop AGPA, minus 16 IR plus 40 I dash R equal to minus E, or minus 16 I plus 40 I dash equal to minus E by R, equation 1A. Or minus E by 2 minus I dash R plus I minus I dash into 14R equal to 0. Now adding 1 and 2, this is equation 2, this is equation 1. Adding 1 and 2, we get minus I into 2R plus E minus E by 2 minus I dash R equal to 0. Or taking this to this side, so 2IR, and again it is also I dash R equals to E minus E by 2 will be equal to E by 2. So now 2I plus I dash equal to E by 2R. This is equation 3. Now 1A plus 8 into 3 gives minus 16I plus 14I dash plus 16I plus 8I dash equal to minus E by R plus E by 2R equals to minus E by R plus 4E by R, or this will cancel, and 40I dash plus 8I dash 22I dash equal to minus E by R plus 4E by R equals to 3E by R. Hence I dash will be equal to 3E by 22R. Answer.